Hi guys, it's Mrs. Milson. Let's do the check your understanding on page 503. Okay. Refer to the previous example about the company's customer satisfaction survey. Okay, let's look at the previous example. What they did over here on this page was they wanted to do a sample survey to rate figure out what proportion of their customers are satisfied. So they wanted to do a 95% confidence interval. So they found a critical Z, and they wanted to be, the confidence interval to have a margin of error within 0.03 or 3%, okay? So there's our margin of error, and I'll go over this in a second. They didn't have a p-hat, okay? They didn't have a sample proportion because they hadn't done it yet. They had to figure out how many people to ask first. They had to solve for n. So they used 0.5. If you don't have a p-hat, 0.5 is fine. It's a nice little, right down the middle estimate of a proportion of a p-hat, okay? So what we're going to do, we are going to use 80%, because in a company's prior year survey, 80% of customers surveyed said they were somewhat satisfied or very satisfied. So we're going to use that value for our p-hat. And we're going to find the sample size needed for a margin of error of 3% at a 95% confidence interval, okay? So for our example, let me move my book, sorry. So for number 1, we are told we're going to use p-hat of 0.80 for our 80%, okay, p-hat. We want to know our margin of error of 3%, and again, we're going to be at a 95%, confidence level. Now let's remember, this is our formula for a confidence interval. This is the only part. This up here is the margin of error. So that's all I'm concerned with. I don't really need the point estimate, okay? So all I'm really concerned with is that this part is within 3%, okay? So this can't be greater, it has to be within 3%, so 3% or less, okay? This is obviously what we're solving for. We're going to use 0.8 for our p-hat, so 0.03. I'm going to leave space for that critical Z. So we're going to use this, okay? So we have to figure out our critical Z, and I know the example showed you how to do it, but I'm going to do it with you anyway, okay? So again, that critical Z is just a Z-score for the middle 95%. So if this is the middle 95%, you know the two of these together are 5%, so each of them have to be 2.5%. Okay, so this critical Z is going to have the area of what? 97.5%. So I'm going to look up 0.9, or I'm going to put in my calculator inverse norm for 0.975. So let me clear that from the other one. Inverse norm 0.975. And there's my critical Z. And again, take it to 3 decimal places. So 1.960, okay? So my critical Z is 1.960. So that's what I'm going to fill in here, okay? So now all I got to do is solve for n, okay? A little bit of algebra. I got to divide, then I square, okay? And then I divide. And then to get rid of that square root, I square, so I end up with that, okay? And then I can just switch all this. So n is going to be greater than 0.8 times 0.2 all over this quantity squared, okay? You throw that in the calculator, and you'll get something like 682.95. So, of course, it's a sample size. We cannot have a decimal, okay? Naturally, I would round up, but you're going to round up always. So my sample size has to be greater than 683 customers in this case, okay? Since this customers, put too many bumps in there. Let me rewrite that. Okay, so for this example, it's customers, okay? Okay, so that's our first example. Now, the second question says, what if the company president demands a 99% confidence? So he wants a 99% confidence level. Okay, so of course, the wider the confidence level, sample size is probably going to go up. Okay, so really, the only thing that's got to change in this equation is my critical z. Okay, Kitty's hitting my paper. Still want the margin error within 3%. I don't think he changed that. He just wanted the confidence level higher. My sample p hat, my sample portion is still going to stay that, and that's still going to say 1 minus t, 1 minus p. So I can just set this up and change the critical z. I'll leave some space for it because we'll figure it out. Okay. Oops. So let's come over here and figure out our critical z for 99%. So again, if this is 99% in the middle, you know, this is 1% on the tail, so each of them is 0.5%. So this would be 99.5% from that z-score on. So I'm gonna put inverse norm 0.995. Oh, look, I still have the other one. I should really just go up and change it, but I'll go through it. 0.995. Okay, and again, let's take it to 3 decimal places. So 2.576. So the critical z is 2.576, which I will go ahead and put in my equation. And if we recall from the setup up here, and I'm just going through algebra, dividing, squaring, and then flipping, it'll be 0.8 times 0.2 over squared. Okay, so I can throw that in the calculator, and I'll get something like 1,179.69, but again, can't have a portion of a person because these are customers, so I'm going to say my sample size has to be greater than or equal to 1,180 customers. Okay, that's how we solve for sample size for the margin of error in a confidence interval for population parameter. Okay. Oh, then it said, I'm sorry, it said determine how this would affect your answer to question 1. Oh, we already knew that. We knew the sample size was going to go up from 683 to over 1,000. Because if you're going to be more confident, you're going to ask more people, obviously. Okay. And think about it mathematically. Mathematically, your confidence level is going to change your critical z, and the higher confidence level goes, of course, higher